We are looking at that if the angle between force and displacement. So if this angle is less than 90 degree, if theta is less than 90 degree, so if theta is less than 90, so cos theta, if theta is less than 90 degree, which means theta is less than, theta is always positive. It is greater than 0 or it is always positive. So whenever the cos theta is positive, so work done is always positive. So always remember, for the positive work, the condition is that theta must be less than 90 degree. So here some examples are given. When a body falls freely under gravity, so angle becomes 0. So work done by the gravity is positive. So this is first example that the work done by the gravity is positive, because let's say there is a ball is falling, free falling. So gravitation force in this direction, displacement is also in this direction. Angle becomes 0 degree. Angle between force and displacement. And when a horse pull a cart, the applied force and the displacement are in the same direction. So the work done is by the horse is positive. You can remember any 2 or 3 examples that I know. Okay, so when a gas filled in a cylinder fitted with a movable piston is allowed to expand, the work done by the gas is positive because the force due to the gas pressure and displacement act in the same direction. So let's say there is a container. In container there is a piston and there is a gas. So if the gas is applying some force to lift this piston upward, so this is the displacement of piston. So this is the direction of piston in the y direction, and force is also in the y direction. So work done become positive. Always remember, just check the angle. If angle is less than 90, angle between force and displacement, then we can say the work done is positive. Next thing is, when a spring is stretched, both the stretching force and the displacement act in the same direction, so the work done is positive. When we stretch the spring, let's say there is a spring, and when we applying some force, so this spring get stretched, so there is some displacement of the string, so force and displacement in the same direction, so work done become positive. Next thing is negative work. So if the force acting on the body has a component in the opposite direction of displacement. So if the force acting on a body, so let's say this is a force and this force is acting on this body, and it has a component that is acting opposite to the direction of displacement. So this is the direction of displacement. This body is moving in this direction, positive direction. So this is the direction of displacement. This is a displacement vector. So if the force having a component in the opposite direction of the displacement, what is written? The force acting on the body has a component in the opposite direction of displacement. The work done is negative. Work done is negative. So always remember. So when this component will become in the opposite direction, when the theta, you can see this theta. So this angle is more than 90 degree. So always remember, when the angle is more than 90 degree, this work done become negative value as shown in the figure. Okay, so when theta is obtuse, obtuse means when theta is more than 90 degrees. So cos theta is uh, uh, sorry, work done is negative. Cos theta is negative, so therefore the work done is negative value. Now let's look at some example. So example, when a body slides against a rough horizontal surface, its displacement is opposite to the force of friction. The work done by the friction is negative. So as we know, if there is a body, if body is moving in this direction, so we know the friction force in this direction. There is a friction force, and we know the direction of displacement vector is this vector. So if force and the displacement are in opposite direction, which means the angle become 180, and we know cos 180 is -1. So the work done will become negative. So this is an example. If they ask about the definition, what is the negative work, and write down the example, so you can write. Now let's move to the next topic. Okay, so here are some more examples of negative works are given. When brakes applied to a moving vehicle, so the work done by the braking force is negative. So the braking force is negative. This is because the braking force and the displacement act in the opposite direction, because braking force resists the motion. So to resist the motion, it has to apply the force into the opposite direction of the motion. Let's say in this direction, if the motion is happening, it has to apply the force in the opposite direction to stop its motion. So therefore again they are opposite in the directions. Okay, so the braking force and displacement act in the opposite direction, so work done is negative. Next is when a body is lifted, the work done by the gravitation force is negative. So when we lift the body from the ground, so what happened? Okay, the work done, okay, so work done by the gravitation force is negative, because so we know the direction of gravitation force is always downward, and if we're lifting the body upward, so the displacement is upward. So if directions are opposite, we know, so that you can learn. These are the examples. Now the zero work done. So work done by force is zero if the body gets displaced along the direction perpendicular to the direction of applied force. Okay. So work done is zero when the theta will become 90 degree. Means we are applying the force in x direction